In this video, we're going to talk about separable differential equations. Alright, so earlier we learned about differential equations. They're just any equation that involve a derivative. So I have dy dx in this equation, that's a derivative equals 2y. Here we have the second derivative and the first derivative. Here we have these two derivatives. If a derivative is involved in an equation, it's a differential equation. Alright, so far the things we've learned with differential equations, we learned how to verify solutions. So we're given a potential answer. We take its derivative and plug it in to see if it is an actual answer. We need the equal sign to be true. And let's talk about how to create and reason with slope fields. So for every, like for this problem, I could plug in an x and y, figure out dy dx, which is the slope of the tangent line, and it gives me all these little lines and creates this kind of wind current almost of the solutions. Alright, however, we've not yet found how to solve them ourselves and actually find the solutions. So when we're verifying they're given to us, now we actually want to find the solutions. And here's a bit of a warning. All right, if you have a STEM major in college, chances are you're going to have to take an entire course, like an entire semester-long course. You might even broke it up into 2 semesters called differential equations. All right, so you'll learn all about them. You'll probably learn pretty much everything that we learn in this class in the first week. And so there's a lot to learn about differential equations, but we're just going to focus on one type of differential equation called a separable equation. All right, so separable equations, any differential equation where you can kind of move things around till you get the part with x's and a part with y's kind of separate from each other. All right, that's why it's called separable, because the x's and the y's, we can get them to where they're not interacting with each other. And this is going to help us kind of move the y's to one side, the x to the other side, and then we can integrate. We'll see that in a second. All right, so this is a separable differential equation. All right, the basic idea is I have this kind of x piece and this kind of y piece. On the left-hand side, I have this y piece and this x piece. I'd move the x pieces to the same side and the y pieces to the same side. So what I'm going to do is multiply. I'm going to have 3y squared dy equals x minus 1 dx. But if you were to kind of like cover up half the equation, that looks like a thing where we normally have the integral signs in front of it, because we have something dy, something dx. All right, well, that's exactly what we're going to do. We're going to separate these, y's on one side, x's on the other, and then we take our antiderivatives. So 3y squared is going to turn into 3 reverse power rule, y cubed over 3. And then again, when we take the antiderivative, the dy goes away. The integral of x is x squared over 2 minus x plus c. Technically, there's a plus c on both sides, but you could just like subtract the c over here and just get a new c. So we're just going to put a c on the x side. If you put a c here and then moved it over, there's nothing wrong with that. Basically, you're just combining them into a single c. We don't know what the constant is anyway, so we might as well just use one of them. This is going to cancel or simplify a bit. And generally, when we want a solution, we want the explicit solution. We want to solve for y. So in this case, I'm just going to take the cube root of both sides. I get y is the cube root of x squared over 2 minus x plus c. And that is our final answer for our differential equation. So if I were to take the derivative of this and plug it in here, then I would get an equal sign that makes sense. Right, so here are the general steps we did when you're trying to solve a separable differential equation. First of all, it's called separable, so we're going to separate the y terms on the left with the dy, the x terms on the right with the dx. Then we're going to integrate both sides, so we're just going to take antiderivatives of both sides at the same time, making sure we don't forget a plus c. You can put plus c on both sides, but again, you're just going to move it over anyways, so just put a plus c on the x side. All right, and then we want to solve for y, and that's going to be our solution to our differential equation. So now let's just do some more examples. Dy dx equals xy, so we want to keep this x on this side and move that over. I'm going to take this y and get it over there. So we're going to have to divide by y. I like to think about it as 1 over y dy equals x dx. Now that I got them separated, now I take my antiderivatives. The antiderivative of 1 over y. This is the reason we had to wait until now to talk about differential equations, because a lot of times you get these fractions you have to take the antiderivative of, and the antiderivative of that is the natural log of y. And on the right-hand side, we just do our reverse power rule, add 1 to the exponent, divide by 2. Now we need to solve for y. How do you get rid of a natural log? One thing that's really important to remember with logs and exponentials is that they're opposites of each other. So if I take the left-hand side and raise it to an exponential, those cancel, and I just get y plus e to the x squared over 2 plus c. Okay. For our test, I am 100% fine with this final answer. This is a great answer. In my mind, it's perfect. On the AP test for a multiple choice question, this is not the way the final answer is going to look. The way the final answer is going to look is they're going to do 2 extra steps. First of all, if you are adding exponents, that's the same as if you are multiplying these together. All right, generally we go from right to left, but it also works going left to right. So you add exponents together when you do something like that. And then e to a constant is still just another random number that we don't know. So they're going to replace this whole thing with just its own c. All right, so they might do something like that. So maybe this is a lowercase c, and this is an uppercase c. Maybe this is c1, and this is c2. But this is the way they're going to write their final answer, probably without the 2. Kind of moving this c out to the front. All right, so that's just the thing you have to be aware of. Again, for right now, as we're learning the techniques and stuff, I am perfectly happy with this answer. But just know, in the future, we have to do some manipulation with c's to get down to here. All right, here's one you try on your own. All right, solve this separable differential equation. I'll show you the answer in 3, 2, 1. So when you do the whole process, you should get something that looks like this. All right, so we need to get this 4y over multiply dx over. Then we can take the antiderivative of both sides, do the reverse power rule, add, divide. Derivative of cosine is, antiderivative of cosine is sine. All right, now we need to get y by itself. So first thing is get rid of this 2, and then take the square root. We get our final answer for this differential equation. So here are the important points. All right, in class and on the AP exam, these are the only types of differential equations you're going to be asked to solve. So it's asking you to solve a differential equation. It's going to be separable, so you know the steps to do already. All right, like I said, in college, if you have to take differential equations, you're going to learn a lot of different ways. You have to figure out which way it works. I've written this a little bit easier. You know it's always separable. All right, so separate the x's from the y's, take antiderivatives from both sides, and then solve your equation for y.